Hello, everyone. We're starting session number 2. It's everything about Starknet Wallets. We have Argent, Braavos Wallets, and Cartridge. We have Julien starting first. And thank you, everyone, for coming. And also thank you a lot for Julien, Yoav, and Tarrance for letting us know all about what's going on with Starknet Ecosystems wallets. So I'll leave the floor to Julien, and thanks again for coming here and letting us know about this cool new thing that's happening with wallets.
Thanks a lot, and thanks for having me. And happy to kickstart this session on wallets. So I'm Julien, one of the 3 co-founders of Argent, and today I'll be talking about ArjunX, the first wallet on Starknet, on which we've been working for the past 6 months. But before we talk about wallet, I think it's important to discuss a little bit more about accounts, because accounts on Starknet are completely different than accounts on Ethereum. And if you want to understand what wallets can do and can be on Starknet, it's important to understand what accounts are on Starknet. And so I'll start this brief talk on discussing Ethereum and Starknet accounts, and then I will go to ArjunX and show you how it works and what it can do and what we are cooking for the next 2 to 3 months. So this is very general. I'm sure you all know this, but on Ethereum, there's 2 types of account: externally owned account called EOAs and contract account. And externally owned account are, as the name indicates, what can trigger transaction because they are controlled by something external to the blockchain. They have an address for identification, a nonce, and a balance. And a user owns an EOA through a pair of cryptographic keys that we can also call a signer. And how is the account linked to the signer? It's because the address of the account is derived from the public key of the signer, and only the private key can trigger transaction from that account. And on Ethereum, we also know that the crypto is hard-coded. We are using ECDSA for signature on a very specific elliptic curve. So if we try to represent that with a visual representation, we see that to understand account, we have in the user space the signer, and then on the Ethereum space, we have an EOA with the address, the nonce, and balance, and then some hard-coded logic in the EVM, which really define how a transaction should be validated and how it's executed. The details are not that important, but what's important is to see that all this is hard-coded and that it really creates a strong coupling between the account and the signer. So on Ethereum, we can say that the signer, the concept of the signer and the concept of the account are merged, right? The account is that entry on the blockchain that holds your token, while the signer is what you use to authorize someone to spend these tokens. And on Ethereum, these 2 concepts are completely merged. They are 2 sides of the same coin. And why is that a problem? Well, I think the past 10 years of Ethereum has shown us why. It's because if the signer is the account and vice versa, that means that if I lose my signer, I lose my account. And if I control your signer, I control your account. And there's nothing you can do, right? There's no safety net. So on Ethereum today, the entire security of EOAs relies on users managing a single secret, the private key, also called the seed phrase, recovery phrase. It's the same thing. And we believe at Argent for the past 4 years that this will not work for mainstream adoption. So we need to find a better solution. And fortunately, there is a better solution, and it's called account abstraction. The idea of account abstraction is to really decouple these 2 concepts. So really decouple the signer from the account. How do you do that? By making the account a smart contract, meaning that the logic of that smart contract can be customized when the account is deployed, and it can decide what a valid transaction is and how to execute that transaction. So for example, you can deploy an account with a different signature scheme than ECDSA, or use a different elliptic curve, or maybe you want to use multiple signer and have a multi-sig, a native multi-sig at the level of the account, or maybe you want to rotate your signer, and so on and so on. So with account abstraction, we have that decoupling, and that opens a completely new design space for what an account and a wallet can be. And what's very exciting is that Starknet is the first layer 1 or layer 2 that is actually supporting native account abstraction. And that's one of the things that got us very excited at Argent. And we really believe, we are convinced that this can drastically improve the user experience of interacting with the blockchain. Not getting into the detail, we've been working with, with StarkWare and OpenZeppelin on defining what should be that interface for an account. Because even though it's a smart contract that you can customize, it still needs to comply and has some constraints. So it needs to comply to an interface that we have defined. The only thing that you need to know is that, excuse me, there is two methods, one to validate and one to execute transaction. There is a method to verify off-chain signatures. That's very important for you as an app developer, but I'll come back to that in a second. And finally, we've actually pushed StarkWare to add multicores by default. Because we're starting from a blank page, we wanted to bring some of the cool features, that were not available on Ethereum. And again, I'll explain what that means later. But you can remember that on Starknet, you have native multicores, and that's a really big deal. So TLDR of what I've just discussed and what you need to remember as a dApp developer is that on Starknet, accounts are smart contract, meaning they need to be deployed. And you may need to consider that. The address of the account is computed like a smart contract. So it's no longer derived from the public key of your signer. Because the account defines what a valid signature is, you cannot assume that there's only one signer. It can be a multi-sig. So actually, transaction can have multiple signatures. Because the account has custom logic, only the account knows what a valid signature is for that account. So if you want to verify an off-chain signature, something like EIP 712, for example, you cannot use EC recover locally. You actually need to ask the account, is this signature on that given message valid? And only the account can tell you if it is or if it is not. And finally, we have multicores. And these 5 points is really all you need to remember about Starknet accounts. And based on that, you will see that we can do a lot of cool stuff. So now that we've briefly discussed what Starknet accounts are, we can now discuss what a wallet can look like. And so I'll be discussing about ArjunX, the first wallet on Starknet. ArjunX is a browser extension that you can have on Chrome or Firefox. It's multi-account, so you can manage multiple accounts through ArjunX. It's a multi-Starknet network, so it works on testnet and on mainnet. It also works on local DevNet if you are building and developing locally. You can, of course, send and receive token as expected, and you can interact with dApps on Starknet. And finally, it's 100% open source, which we believe is very important because we want to make ArjunX the wallet of the community. And so we are really welcoming contributions. And so if that's something that gets you excited, please join our repo and start contributing. We would love that. ArjunX in a few numbers, because it's been an amazing ride since the launch of Starknet. We have today 120K active users. That means people who have installed and used the extension, which is quite amazing. We actually have a funded wallet because Starknet has opened the bridge 3 weeks ago, and we roughly managed 330 ETH and around 150K DAI. Starknet is still in alpha. ArjunX is still an early product, but I think it's very exciting to see that we are actually already serving real users with real money. Okay, now back to the interesting part. So because on Starknet accounts are smart contract, actually a wallet is needs to be 3 components if you want. There's the UI, to which as a user you will interact. There's also a smart contract that needs to be deployed, managed, and interacted with on chain. And then there's one or more keys that can sign transactions for a given account. So if you think about ArjunX, you need to think about these 3 components: the UI, the account contract on chain, and then the key. So how does it work for a user? Very similar to a flow for, like with MetaMask. If your dApp is on Starknet, the user can connect a wallet. When the user clicks on a button, this will trigger ArjunX to open. You can approve the transaction. The wallet will use the key to sign, send a transaction, and call the execute method of the account contract. The account contract will validate the transaction based on whatever logic is defined on the account, and then we'll ping the target dApp contract to do the target action. So that's a very normal flow for a wallet on chain. And as a developer, what you need to know is that on your dApp, you need to use Starknet.js, which is a JavaScript library to interact with Starknet. And actually using another library, another NPM package called Get Starknet, which will inject the correct signer into Starknet.js, and it will automatically trigger the interaction with ArjunX. So as a dApp developer, you build your dApp using Starknet.js, and you make sure to use get Starknet to inject wallet into the page. Okay, what are some of the cool features that we can have with the wallet and that we do have on ArjunX? The first one is MultiCore. The idea of a MultiCore is to actually execute a sequence of operation in one atomic transaction. So typically on Ethereum, for example, let's say you are building a dApp for a lottery. When the user wants to call a method to buy a ticket, it needs to first enable a token, and then the dApp will consume this token when the method is called. So the flow for a user is first an approve of your token and then calling the dApp, typically 2 operations. With a multi-call, these 2 operations can happen in sequence in one atomic transaction. But actually, it's not restricted to just 2 operations. You can imagine that you want to send token to 10 different parties. You can actually chain all these operations and execute them in one atomic transaction. So why is that a big deal? Well, first of all, that means the user signs only once. In terms of UX, it is much better. Asking the user to approve a token, wait for that transaction to become firm mine, and then click on a button to interact with the dApp is a painful experience. With multi-call, everything can happen in one transaction. And even more interesting is that it can save a lot of gas. Why? Because on Starknet, the majority of the costs come from the state diff. So every time you do a transaction, if there are updates in the state, these update needs to be pushed to L1. And that's actually the majority of a cost for a transaction. But because of a multi-call, you can have operation where the end state, even though the state of a certain storage slot may change between the different operations, in the end, it is at the same value as the beginning of the transaction. Think of an approve and a call, for example. You first approve a token, then you call your dApp, which consumes the token. So at the end of the operation, the approve is back at the initial value, meaning there is no state difference, meaning there is no cost to pay for that. And actually, you can, as a developer, you can start thinking about that and start leveraging that to make more complex operation and reduce the cost of these operations. And so some cool example is the approve and call that I've just mentioned, but you can do a multi-send. You can send funds to many people in parallel. If you're building a game, you can start to do batch transactions, so you can collect operation and execute them all at once, depending on the flow that you want to have for your games and so on. If you look at the screen from ArjunX that I've pasted on that slide, you see that here we are swapping one token for some DAI, and that we're actually sending this DAI to 2 different persons. Everything happened in one single transaction, so one confirmation for the user. So that's a native functionality of Starknet, and that's something that as a dApp developer you should really think about, because it really can improve the UX of your dApp. Another thing that is coming to ArjunX, that's something that is actually there, but only that we are currently testing, is what we call transaction review. A major pain point of I think interacting with dApps is that usually you don't really know what you are signing. The idea of our transaction review is to make all that information human readable. And actually, for the dApp that we know, we can even decode that information and provide relevant information, such as the name of the dApp, or the name of the token that you are sending, or the value of that token, and so on. And furthermore, what we are bringing is also adding a rescore to the multi-call that you are executing, so that to the transaction that you're executing. And this rescore can tell us if the action is verified, because we know it's a known dApp, and we know that the operation, the method you are calling is legit, so we know that everything is okay. So we can show you that in the screen and say, you know what, this transaction has been verified, you're good to go, no stress. If we don't know, we don't tell you anything, we just show you the transaction as it is. But sometimes we can also detect that something fishy is happening, or you are making a mistake. And in that case, we can warn you. An example that we are seeing a lot is actually people, it may sound a bit silly, but there's a lot of people who send ERC20 token to the ERC20 contract himself. I mean, that's a silly mistake that people may make. And actually using our transaction review, we can flag that and let the user know that his transaction is actually, he should check his transaction, because he's about to do something that shouldn't happen. So the point of that feature that should be available hopefully with the next release is to really bring confidence when you are transacting on chain, because we believe that's something that's very important. Another thing that's coming is fiat to crypto on RAM. So today you can connect with ArjunX to you can bridge ETH or DAI from Ethereum. You can receive from another Starknet wallet, but we're also working with on-RAM to enable you to actually get crypto using a credit card or a bank transfer. So we are partnering with Banksa. We were waiting for 0.9 to be launched on mainnet, which happened today. So we will release that very soon, but we're also discussing with other provider, and we will basically give you the best provider depending on your location. So again, something that is coming in the coming week. Now, these are, I would say, short-term feature. Now, about the exciting stuff. Because we have account abstraction, we can do a lot of new things. And at Argent, actually, we've been thinking about these things for the past 4 years. Because for those who know us, I mean, we're building a smart contract wallet. We've been building a smart contract wallet on L1. So we've actually implemented all of these ideas, except that on L1, it was a bit more clumsy, a bit more expensive. Now we can bring all these cool ideas and cool features at the level of the account, which we find very exciting. So the idea of session keys, for example, in the context of a game, is to really improve the UX. One problem with blockchain game is that every time you make a transaction, you need to confirm that on your wallet. And of course, that's not a good experience for a user. With a session key, because the account is a smart contract, you can program the logic that you want. For example, you can, in certain situations, add a new key to your account, which has some special rights. And so the idea of a session key is that the dApp will actually generate a key locally, will ask the user to approve that key with some constraints, such as that key is only valid for 25 minutes, and it can only call the 2 contracts of the dApp and these 3 methods on each contract. So you can really constrain at the blockchain level what the key can do. So that's one approval on your ArjunX wallet. That's fine. And what's interesting is that after that, the game can actually make transaction and call the account directly without having the user to confirm anything. So that's really an amazing experience when you want to play a game. And what's great is that you only need to approve the session key. And after that, you know that this transaction, your assets are secure. You know the perimeter of the action that the session key can do. And for those who were at the Starknet Hackathon in Amsterdam, the people from Brick and the people from Realm act around that idea, and actually they won the hackathon using this concept of session keys that we are building with them. And so this, the contract is already ready, needs to be, of course, audited, and we hope to have that available for games at the beginning of this summer. Another cool thing that you can do with account abstraction is the concept of fraud monitoring. So I've shown you the feature of transaction review. That's great. That's really providing information about the action that you're about to do with your wallet. But you can actually go one step further. And you want, when the action is a warning, you may want to block that transaction, or you may want the user to confirm his identity before executing an operation. And that's the idea of fraud monitoring. Let's imagine that you program your account to now have 2 keys. There's the main key, the owner key, that's controlled by ArjunX, and so by you, the user. But you can also add another key, and you give that second key to a service. And now every transaction needs to be confirmed by both keys, so signed by both keys. So let's imagine that as a user, you interact with a dApp, which is whitelisted. It's a legit dApp. You click on a button, ArjunX will send the transaction to the fraud monitoring service, which will evaluate that the dApp is verified. The fraud monitoring service will automatically send his signature. You approve and you send with the key in ArjunX, and now the action is executed because you have both signatures. That's great. Now let's imagine that you are going on a fishy website or a malicious website. You think that you are clicking on the button to do something, but actually you are interacting with an evil contract that will steal all your tokens. When in that case, the fraud monitoring service, let's assume it knows that this contract has been blacklisted. It will detect that because you send him the raw transaction, detect that it's an evil contract. It will actually block the transaction and will tell you why, and will refuse to send you his signature. Or you can imagine that someone has hacked your computer, So that, I mean, it can really block transactions that are known to be fraudulent. And of course, if you're in between, if it's a call that the fraud monitoring service doesn't know, it may, for example, just ask you to confirm your identity because it doesn't know if it's a valid call. It just, it sees a request, it asks you, please confirm me that you are you, and you may confirm that with 2FA, with email, SMS, Google Authenticator, you may choose. And if you prove that you are the legit owner of the wallet, it will send you the signature. So that's typically the kind of experience that you will see in a bank, except that it's fully non-custodial, because as the owner, you choose who you give that key to. You can give it to fraud monitoring service A. If you're not happy, you can give that to fraud monitoring service B. So it's really a way to bring security on-chain. The last thing that I want to discuss, on which we are working, is what's called social recovery. So for those who know Argent, that's something that we pioneered 4 years ago. And of course, we are bringing that to the Starknet ecosystem. The main goal of recovery, social recovery, is to get rid of seed phrases. I don't know for you, but I think seed phrase make no sense. It's a security nightmare. And again, the ecosystem will never scale, will never grow if the entire security of a user relies on him, keeping securely a seed phrase or a password. So we need to have better mechanism, and recovery is a solution to that. The idea of recovery is, again, you program your account, you add a second key. In Argent, we call it Guardian, and that key cannot trigger transaction. It cannot do anything, but just call one method, which is the recovery method. And so imagine that you lose your computer, so you've actually lost the key that was controlling ArjunX. With a MetaMask, you would use your seed phrase, but here you don't need to have a seed phrase. What you do is that you call the recovery service, you prove that you are you. Again, may happen on the phone, maybe you need to show a passport, maybe it's 2FA with email and SMS or Google Authenticator, doesn't matter. You prove to the recovery service that you are the real owner of that account, and the recovery service will trigger that only transaction it can do on your account and reprogram the account to set a new owner key. And automatically you are good to go. So no need to have a seed phrase, and you're still protected in case your account is your owner key has been lost. Again, not going into the details here, but it's 100% non-custodial. And what's great is that we can finally get rid of seed phrase and provide a Web2-like experience, but still 100% non-custodial and 100% secure. All these three features that I've just discussed, so session keys, fraud monitoring, and recovery, they are there. Recovery and fraud monitoring, it's already supported by the Argent account smart contract. We just need to surface them in the UI. And session keys, the contracts are there. It will require an update of your account contracts, but that's fine because it's a proxy. So these are not crazy ideas that will come. These are stuff that will come in the next 2-3 months. Okay, I think I'm getting towards the end of my talk. So how to get started? Very easy. Use Starknet.js, as I mentioned, and use Get Starknet, and automatically you will have access to ArjunX. Not only ArjunX, because Get Starknet is actually multi-wallet. So as I'm sure Yoav will show you in the next call, by using Starknet.js and Get Starknet, you actually have access to ArjunX and to Braavos, which is really cool. And that's it. Thanks for your attention. If you want to know more, please check our website. And if you haven't done so, please install ArjunX on the Chrome Store or Firefox.
Thank you, Julien, for this wonderful presentation. Is it possible to push the Q&A session towards the end of all the presentation? We'll have Yoav present Braavos wallet, and then we'll have a Q&A a little later. Yeah, thank you, Julien, for your presentation, and we'll move to Yoav. Hello, thank you for taking your time, and thank you everyone for taking your time to come all the way to learn more about Starknet Wallets. And we're super delighted to hear from you, and I'll hand over the floor to you.
Hey everyone, let me share my screen for a sec. One moment. Right, sorry, Zoom is not, we use Google Meet, so I don't have Zoom authenticated. One sec, I'll rejoin in a sec. Let's see if it will work. Yeah. Right. Right, something is not working, so I'll just share it via the keynote. All right, hey everyone, nice to meet you. I'm Yoav from Braavos. We're doing a smart contract-based wallet, non-custodial. Just like Julien said, we have a bunch of cool features in our backlog, just waiting to be rolled out for you guys. But my session is actually, I wanted to be a bit more technical. So I wanted us to demystify what's going on between the wallet and the smart contract and get a bit into the nitty-gritty details of what's going on. All right, so under the hood of every wallet, every smart contract wallet like ArgentX or Braavos, there's an account contract. And we want to take a look inside and see what's going on there. So our agenda here is we will run over setting up an environment, deploying an account contract, and then we'll take a deep dive and look at the execute function, which is the main function of the account contract, right? This is what enables us to actually call other smart contracts on the Starknet network. And you could also see that on at Julien's slides, that he had a bunch of errors going into the execute function, so we'll demystify it. All right. So first, we need an environment set up as a playground. You need a Python bigger than 3.8, newer than 3.8. If you're on the Mac M1, I strongly suggest use 3.9 and a later one of that, 3.9.12, otherwise you'll have dependency issues. You need to install Starknet DevNet. In this case, I installed the previous version. Let me show you. All right. So I have Starknet DevNet installed here already. Version 0.2.2. The latest version is 0.2.3, but I use this one so it will be compatible with the contract that I'm using in this presentation. You need to install Cairo Nile, which is a Python wrapper around that gives you a lot of convenient functions to mess with signatures and other stuff that the account needs. I will provide a GitHub repository with the account contracts that I used for this session. And now let's compile the two contracts that we need for this session. So in order to compile, I'll just need to Starknet compile. It's pretty easy. So I have the contracts here. Actually, I already have them compiled, so let me remove them and compile. So to compile an account contract, I used OpenZeppelin's account contract. Okay, you can find it in their GitHub. I'll provide a link as well. So we'll use Starknet compile. And we'll output it here. And we'll output the ABI here as well. And for account contract, we actually need to tell the compiler that we are compiling an account contract because of the execute function, all right? So here it is. You can see that now I have account contract, the account contract compiled as a JSON file and the ABI. Now let's compile the other. Which is a malicious contract, actually. Right, and you can see that I have the malicious contract compiled here as well. All right. So now I also want to run the DevNet, which is a local instance of Starknet and can allow you a much greater flexibility when you want a playground, right? Instead of doing stuff against the testnet or mainnet, if you have the money, Starknet DevNet is a local instance developed by the Shard Labs guys that allows you to run a local instance of Starknet, which is very cool and very convenient. So let's run it here. All right, I have it already running probably. Yeah. All right, now that I have it running, I want to set up my environment to point at it. When you use the command line Starknet, it uses, you can either provide it with actual gateway URLs, you can see the feeder gateway and the gateway, or you can use environment, right? So I will also include it in the repository, but we have here the environment that points to DevNet, all right? So I'll just source them. All right, now that we have everything set up, we're ready to go. First, we want to deploy the account contract and the malicious contract to DevNet, right? If we'll take a short look on the account contract, let's find it, then we can see that its constructor accepts a public key. So this means that I need to create a public keeper, a Starknet public keeper, in order to construct the account, to construct and deploy the account contract, all right? So in order to create the public and private keeper, I'll use the Nile tool that we installed previously, which is very convenient. And I'll just, as you can see, I already imported it into my Python environment. So let's create private key. And now we can take the public portion. Signer. I wrote singer. Now we have a public key that we can use to deploy the account. All right, so let's deploy the account. So we're doing Starknet deploy, all right? It requires us to give it a contract. All right, and in the inputs, we'll provide it the public key that we got from the Python part, from Nile Signer. Right, you can see that the Starknet DevNet actually got the request. You can see it here. This is Starknet DevNet that runs on port 5050 on the local host. And you can see that the account was deployed. And this is the account address, right? So let's save it. So we'll have it for later use. Now let's deploy the malicious contract as well. The malicious contract actually doesn't have any constructor parameters, so we can just deploy it in a straightforward manner, all right? Contract. Great, and we have the malicious contract address as well. All right, so now that we have the contract deployed, let's call the get public key on the account address to see that the public key was indeed the one that we set. This is a useful exercise in using Starknet call. We're doing a call, right? A call requires an address. So we have the address from account contract. It requires an ABI which describes to the tool the functions that are exposed in that contract, so we can call them by name. So let's provide the ABI, which is contracts accounts ABI. And the function we want to call, if we look again in the account Cairo, actually we need to look at the library. It has a get public key method that will return the account public key. All right, so let's get public key. Sorry. Let's just copy paste it instead of debugging it. All right, this is the public key that we got. It's in hex. So let's confirm that it is indeed the one that we got from the signer. Yep, as you can see, it's the same public key. So we have the account Cairo deployed, and we have the malicious contract deployed. Let's move forward and let's talk about the execute function. All right. The execute function is the main entry point of the account contract. It allows sending, as Julien said, it allows sending multi-call. So instead of using a transaction per call, we can send multiple calls in a single transaction. It has a lot of benefits, as Julien said, like a reduced gas fee and latency reduction and so on. It also, one of the main objectives of the execute function currently is to also verify that the transaction is valid. It does so by doing two things. It verifies the nonce, and we'll get to it in a sec, and it verifies the transaction signature with the account public key that we just set. All right, so let's take a short look at the execute function. You can see that it gets the call array, all right? The call array is the multiple calls that are done by the user. And if we look at the execute, which is the actual implementation, you can see that it gets the nonce, it verifies the nonce, all right? And if we send with a transaction an incorrect nonce, then it will fail. And it does some crunching on the parameters and validates the signatures. All right, once everything is validated, the nonce is incremented, meaning that the next call have to have a nonce that is higher by 1. All right, so if we want to invoke, we first need to get the nonce. The nonce is, as we saw, the nonce is increased after every transaction and is a part of the call to execute. As we saw as well, the transaction will fail if we send the wrong nonce, right? We see this as assertion. And this basically guarantees that the call that we're doing is applied on the expected state of the contract. So I got the nonce, I now know that the contract is in a certain state, and I make my transactions. If for any reason in the time period before getting the nonce and calling the transaction, something else happened in the contract and its state changed, my transaction will fail because it operates on a different state, right? So this is a very nice mechanism to make sure that you operate on the correct state. And so we need to get the nonce. The account contract have an API to get it. All right, so we can just call it. Let's call it. And you can see that the nonce is 0 because we just deployed this account. Let's move forward. Additional thing that we need for invoking a function is to sign it. All right, signing is a pretty tedious process, and it's good that we have the Cairo signer object that allows us to sign the transaction, and internally it computes the hash on a bunch of parameters that we send, but also on additional metadata that is used to compute the transaction hash. All right, so computing this thing manually is pretty tedious, and I highly recommend that you use one of the frameworks like Starknet JS or Nile to sign instead of computing it yourself. All right, so the hash includes our parameters as well as additional transaction metadata. If you're interested to see how the hash is computed, you can go to the link and check it out. All right, so now that we have everything in place that we need, let's call the malicious contract. Okay, so we're going to use Starknet Invoke. And in order to call execute, we need to provide the following parameters. All right, so we have the call array len, the call array, the actual call array, meaning what we want to do, the call data len, and the call data, what data do we want to add to the call, and the nonce that we need to provide. Of course, all of that needs to be signed. So in order to do that, let's first let's go through here. So call array len. Call array is actually an array of arrays where each object is what I want to, who I want to send to. In our case, it will be the malicious contract. The selector. In this case, in Invoke, we don't have any utility function. We need to send the hash of the function name. This is the way Starknet works. The data offset and data len, we can do a separate session on this data structure. So I'll just breeze through, but we don't have any data when we call the malicious contract. So these two will be 0. And this will be 0 because we have no data. Call data, this is another query. It will be omitted because call data len is 0. All right, so this is a small query. Actually, the function signature contains call data, but if you provide call data len 0, you don't need to provide the call data. I see it as a query. I don't know, maybe other people see it as a mandatory, but well. All right, so let's do it. Let's call the invoke function. So first, let's try and compute the signature. So we know that the nonce is 0, and if we'll do help on signer sign transaction, sorry. You can see that we need to send the sender what we want to do, the calls, and the nonce, and max fee will be 0. This is DevNet, so there's no fees anyhow. So let's do it. Signer sign transaction. The caller is our account contract. All right. And the call, as I shown here, we need the malicious contract and the hash function and the hash of the function name. We have a utility function for that. I'll show you in a sec. So this is the malicious contract. The selector, we need the selector. Sorry, in this case, in sign transaction, we actually can use the function name and not the hash. In the invoke, we will need to use the hash. All right, so if you look 1 second in the malicious Cairo, there's a method called not so honest method. We'll use it. And we need to provide the call data, all right, which is nothing. And this is actually what I forgot to do here, is that this is an array. Like, as we said, it's a multi-call. So we need to provide multiple calls. In our case, it's just a single call. So we're closing the single call, and we're closing the multi-calls, and we're adding the nonce, which is 0. All right. Now we got a bunch of stuff here. The interesting things are this one and this one. These are the signatures, signature R and signature S of the transaction. This is actually what you need to use when you sign the transaction and send it using Starknet Invoke. All right, so let's do it. If you're using Starknet Invoke, let's use address of account address. ABI of account ABI. Function, we're calling execute. Signature, we're calling with these two guys. All right, now we need to actually send the parameters into execute. All right, here we didn't send the parameters, we just computed the signature. As I shown you, we need to send the actual parameters. So in this case, the parameters are call array len 1, because we're using one call to the malicious contract. We need to send now flattened the 2, which is the malicious contract. We need to send a selector, but now we need to send it via its hash. All right, so get selector from name, not so honest method. All right, this is what we need to use when we're calling invoke directly. Okay. Data offset, data len, and call data len will be 0. And actually the nonce will be 0 as well, because this is what we got when we called get nonce. All right, let's pray that it will work. Oh, sorry, I missed the inputs. This is the signature. All right, we send the transaction. Fingers crossed. Let's see what's going on with it. We're using Starknet tx_status and give it the transaction hash. And we can see it was not rejected and accepted on the L2, meaning that everything here miraculously worked. And this was pretty brave to do it in a live presentation. And what I want to do now is to verify that it actually worked. So I'll call all right. So it worked. Okay, this means that it worked. Now let me get back to the presentation. And this is actually where we can start our Q&A, because I wanted first to ask you, what did malicious Cairo did, right? If you guys can guess, what did malicious Cairo do? I remind you, I called get public key afterwards, and I got 1, 2, 3. All right, so basically what it did is to change the public key. All right, it changed the public key of the account, meaning that this smart contract, the malicious smart contract, actually took over my account. Now, there's a very, very, very big lesson here, because if it can change the public key, obviously now it has signing rights and it can transfer all my assets away from the account into his account, into other accounts, do whatever he wants, lock me out of the account, so on. Now, there's a huge lesson and it deserves a series of sessions, is how do we protect and how do we prevent such attacks. You know, we are from Israel, the Braavos team, so we have a lot of experience with all these cyber things. And I think that the topmost advice that I can give you while writing smart contract is minimize attack surface and prevent, you know, be very defensive, even if you think it's redundant. If you are confused whether to be defensive or not, then the default should be defensive, all right? That's it, I'm open to questions now.
Wonderful. Thank you so much for your wonderful presentation. I loved how we show the session. I think we have two open Q&A questions. The first one is, where can we access the Braavos code? If not, do you plan to release it? When?
Yes, obviously we're planning to release it. Once we'll be live on mainnet, we're planning to fully open source the Braavos wallet code. And the code for this session, of course, we will open source right after the session.
Wonderful. Once we get the link, I'll post it in our Discord channel so everyone can have a look. And the second question is, how was the Nile signer used and what was it used for?
All right. So I know that this can be a very confusing part when using, you know, the command line tools without the convenience of other methods wrapping you. But when we call Starknet invoke, actually, if we look at the code, we can see that the execute function, it validates the transaction. All right, now this TX info, transaction hash, TX info, signature, and so on, these things come from somewhere, all right? It comes from when you're calling Starknet invoke, you can see that you can add the signature, okay? Now I need to compute this signature. To compute the signature, it's pretty involved. You need to hash a bunch of things that are related to your call, like the parameters you use, the length of the data that you use, and a bunch of metadata about the transaction. And then you sign it. This is where I use the Nile signer. So you can see I provided all the necessary information for it to compute the signature. And it computed it, it did the hash internally and created this thing, which is, you know, there are some redundant stuff that I won't get into, but this is the actual signature. The last two parameters returning from the function are signature R and S that you provide into the invoke function, right? These are the exact same things. I hope this clears it.
Wonderful. I think that's all the question for this presentation, and I really thank you for your time and letting everyone over here know more about Braavos wallets. And if anyone has more questions, feel free to ask it in our Discord. I'll revert back to you so if he can answer later on.
All right, thank you, guys.
Thank you. We'll move next to Tarrance. Hello, Tarrance.
Hey, how's it going?
Great, great, great. Thank you for your time. And we're moving to our third presentation with Tarrance about Cartridge. I'll leave the floor to you so you can explain more about Cartridge.
Awesome. Thank you for having me. So let me Can you guys see that okay? Do you share? Do you see my shared screen? Yeah, cool. All right, I'm on the web Zoom, so the UI is a little bit rough. Cool. So yeah, we're working on Cartridge, and Cartridge is what we're calling the gaming console for Starknet. And Cartridge is really a manifestation of some of the things we ran into when building the Dope Wars on-chain game on StarkWare. And something that was started quite early on and has led to, I think, a lot of like interesting developments in the gaming ecosystem for Starknet. And through that process, kind of opened our eyes, or at least my eyes, basically to the power and the unique things that Starknet enables, but also some of the limitations in building a game that we think would be fun to play and can onboard a significant number of users without, having a lot of the overhead that's traditionally involved in interacting with blockchains. So obviously, when you start to put, the drastic increase in compute enabled by Starknet and the ability to put much more compute and potentially state on chain, you have, you increase the number of interactions with blockchains by orders of magnitude. So clearly, there's a need for some infrastructure to try and make that process fun and kind of transparent to the user. So to the extent that is necessary, Cartridge is working, on the kind of the interactions between players and games. We're not necessarily building a wallet ourselves, and I'll talk a little bit about that. I think like the end state looks a little bit different from what we see in like the Ethereum ecosystems, and other blockchains today that are dominated primarily by externally owned accounts. But yeah, so that's what we're building at Cartridge. So the Cartridge, top level, I'll show you some UI of the application just to better communicate what we're building. At the top level is basically the arcade, where you can find different games that people are building on the Starknet ecosystem, and there's quite a few of them being built out today. There's the game profile page, which is really an integration point and a place for different protocols to interact with different games. So as a player, you might own assets and want to interact with different DeFi protocols, like potentially like automation protocols or marketplaces or loaning applications and stuff like that. So providing a place for you to do that as like the asset owner or a player in a game, or potentially help onboard players into your gaming universe. So that, in the blockchain space, a lot of times when you have games, you require, for example, some assets or something to play it. So facilitating that process, like really making it super easy for players to start playing games where some of the logic exists or interacts with the underlying Starknet blockchain. And so, to the extent that we interact with wallets or kind of consider a little bit of a wallet is, how do you manage permissions for, so Julien mentioned session keys that Argent is working on. Obviously, something like that is critical for gaming interactions, where you don't want to be able to approve a transaction every time you're making a chess move, for example. So Cartridge is a place to manage those permissions to, kind of broker that trust between a user and the game. So if you're a player coming to a game and it's through the Cartridge ecosystem, and the game is asking for some permissions to execute transactions on your behalf, you can be sure that, or reasonably sure that it's going to do the things it's saying it's going to do, and it's not going to sell your Bored Ape on OpenSea or something like that. And then the APIs that we're thinking like providing as part of this horizontal gaming infrastructure that is kind of on top of the controller component of Cartridge's achievements. So as you have an account in Starknet and the ability to like build a reputation and an identity, like essentially like an on-chain score for your Cartridge controller or your gamer profile over time. So so really what we're building is horizontal gaming infrastructure on the player side to make it super easy and fun to play games that exist on Starknet. And on the game developer side is providing infrastructure to help accelerate the development of the ecosystem. So, there's really not that much interesting about wallets, to be honest. And Julien and Braavos team did such a great job of talking about a lot of the details already. So I really wasn't sure what to prepare for this presentation because I didn't want to just rehash the same things over and over again. So I kind of just created a bingo card of the things at the top of my head that I think are particularly interesting about wallets and accounts on Starknet. So yeah, as like it's been mentioned, like Starknet basically is going straight ahead and implementing account abstraction by default, which obviously is here today, and it is taking a lot of learnings from the Ethereum ecosystem. A lot of these models or protocols have already been defined, and the Ethereum ecosystem is slowly moving towards it, but it's like a very slow and tough transition because of the domination of like externally owned accounts, and essentially because smart contracts have the ability to detect an externally owned account. A lot of the Ethereum ecosystem today is not compatible with smart contract, or some of it like not fully compatible with smart contract accounts. So Starknet really gives us a great opportunity to rethink a lot of that. And some of the interesting, things that I think are going to come down the line or are enabled about account abstraction are things like meta transactions by default. So in Ethereum, for example, as it stands with externally owned accounts, smart contracts of a specific protocol have to implement support for meta transactions. If you're not using a smart contract wallet, like then you have to have like a function call on your like protocol that accepts a signed blob that someone else can submit on your behalf and recovers the signature to verify that it was signed by the externally owned account that is trying to perform the action. So, account abstraction by default means that we can do meta transactions at scale without like all these edge cases, and it's going to be a massive opportunity to make the onboarding experience of Starknet like very seamless. And I think like there's quite interesting infrastructure that can be built there and services that can be offered for the Starknet ecosystem still. I think one of the things that I'm super excited about is the modularity. So, in today in Ethereum ecosystem with externally owned accounts, you have really like this monolithic wallet stack for people where, you have like the signer and you have a Rainbow wallet or MetaMask. You can technically transfer your account between them using your mnemonic phrase, but it's kind of, like almost like a zero-sum game. I feel like people don't really do that. Whereas with the smart contract wallet, you have this ability to implement new things. So you can upgrade your wallet, for example. Julien has been working on like a plugin system, and I think like foundationally, it's going to be really cool if Starknet wallets support plugin systems by default. Like the base wallet implementation should basically just be like a way to plug in to almost like a HTTP routing kind of library, just a way to plug in different authorization routes. And the simplest, most naive one is just like a single signer, which is similar to like an externally owned account on Ethereum. And then you can plug in things like for example, like a Argent Guardians, or if you want, you could turn it into a multi-sig where you could have, a one of n kind of setup where you have one of your signers on your computer and one of them on your laptop, and either one of those can execute transactions, or have, for example, like ephemeral keys that exist in the browser. So I think like the modularity of the ecosystem is going to enable like a different way of thinking about wallets, and it's important for us to make sure that like the interfaces are standardized in a way that it becomes interoperable between different wallet interfaces, for example. And we see a lot of that in the Nonce Safe ecosystem today. So Nonce Safes are essentially smart contract wallets, and there's a lot of like interesting applications building on top of them, which are just a different way of viewing the content of a Nonce Safe and a way of like executing transactions on it. So for example, you can take a Nonce Safe and you can have like you can use it as a multi-sig, but you can also install a module that allows a DAO to control it, for example, or for transaction like validation and verification stuff, similar to what Julien was talking about with Argent, is applications that you can plug into a Nonce Safe that can, look at a transaction and enforce some constraints on it. So say like there's thresholds of value that can be sent at a particular like addresses that it can be sent to, and you can kind of change the level of authorization that's necessary based on the contents of the transaction, which I think is going to be really cool. Yeah, I think the validation path that that implements like the validation logic is really what enables this all. You can think of different signature schemes. So, for example, like because Cairo is very low level and has the ability to support like a lot of different cryptography, you can have a smart contract wallet that's actually just owned by an Ethereum MetaMask account, right? Or one that uses BLS signatures for multi-sig, so you no longer have like the existing flow of aggregating signatures on chain in order to or like aggregating signatures and then like basically having like O of N overhead for the multi-sig signers in order to approve a transaction. So you like dramatically increase the number of signers you can potentially have for executing a transaction. Or you could even have like verification for like WebAuthn or like FIDO keys. So things that exist in the existing traditional world of authentication that the ecosystem is Web2 ecosystem is pushing towards, which is just like generally like very well aligned, I would say, with the crypto ecosystem, which is like the removal of passwords and the usage of public-private key cryptography to secure people's accounts, and kind of see like an intersection of those enabled now with the capabilities of Starknet and account abstraction. So yeah, I think those off the top of my head are really some of the interesting things that are going to be enabled. I'm excited to kind of think through what are the possibilities, and would love to hear any kind of interesting ideas that people have or questions that they have of where this could take the ecosystem.
Wonderful. I think it's a great point to talk about standardization, interoperability, and modularity, especially in for the perspective of Starknet ecosystem focused on game wallets. I would love to open the floor for questions. If anyone have questions to Tarrance, feel free to put it on the chat or the Q&A session. Thank you. You gave a fabulous presentation, and everyone understood. There's one question. It says, you said a MetaMask could own a Starknet wallet. How does that work on a lower level?
Yeah, so because of the lower level kind of the functionality that Cairo enables, and the Starknet team is working on this, which is like basically a way to like recover an Ethereum address from like a signed blob of information, like basically. And I think there actually is an implementation on this that relies on some hints that aren't whitelisted yet. So conceptually, it works very similar to what the account looks like today. That we walked through in the previous presentation, except for like the verification of the signature just uses a different curve. And so it'll be a little bit more expensive since it's not optimized for Starknet. But you could imagine even a workflow where you sign it, you can sign a transaction with a MetaMask or with a MetaMask a wallet, and then that can generate a Starknet native key that can then be used for some duration of time to execute transactions, so you don't have to maintain that constant overhead. So yeah, I think like there's a lot of different ownership models that are going to be enabled by the fact that like wallets are basically just smart contracts now.
Wonderful. We have second question. When will you be launching Tarrance?
Soon. So we just like spun the team up full time, like literally today. So things are moving along pretty well. I think like in the next couple of weeks you'll be able to see some cool stuff that we're working on.
Yeah, feel free to share your launch. we'll be excited to share with our audience. Yeah, thanks a lot, Tarrance. And I see that Julien has answered all the questions that were particularly for Argent, but would love to give floor to Julien to answer everything in person. So yeah, I'll open, ask Julien if he can join. Yeah, thank you, Julien, for waiting for till the end. But the first question was, would you at some point provide the ability to extend the ArjunX account, for instance, to add some validation rules or some signing algorithm?
Yes, so definitely. I think Tarrance just mentioned that, but I've been working on the idea of enabling plugins on the Argent account. So the account has some core functionality, and then you can add some custom plugins to add new features. And for example, the session keys that we are about to bring relies on that. So the session key is actually a plugin. And so the idea is to make the account a bit more modular. Of course, there's some, you want to make sure that you control which plugin are added. So there is some security aspect to that. But yeah, the idea is really is to make the ArjunX a bit more like a platform on which you can add functionality. So 100% yes, the idea is to let developers or to enhance the functionalities of the wallet using plugins. Yes.
Wonderful. Second question is, so there is still an EOA on ArjunX because wallets are smart contract wallets, but only an EOA can trigger a transaction.
Yeah, no. So what you need an account to start a transaction on Starknet, and as we've discussed, account are smart contract. So you don't need, there's no concept of an EOA. Every single transaction must start its journey from an account who will then pay the fees for that transaction and the entire execution, but there's no EOA needed. Of course, depending on the authentication of your account, you may need to have a key that will sign to be authorized, but the transaction starts from the account. So no more EOAs on Starknet.
Wonderful. Next question is, by multi-transactions, do you mean multi-simultaneous transactions?
Yeah, well, yes. Well, you can think of them as a sequence of transactions being executed in one blockchain transaction. So from the blockchain's point of view, it's just one transaction, except that that transaction encapsulates a sequence of execution that can be completely decorrelated. So for example, you can make 10 transfers in one transaction. So what typically would require 10 transactions on L1, here you bundle them in a sequence or a multi-call, and then in one transaction, that means one signature, one execution, you actually execute the batch of inner transaction if you want.
Great. The next question is, the account recovery feature is awesome, but does one need to do a KYC in order to recover?
Yeah, that's a great question. So no, the idea of recovery is that the only thing that, anything that can sign can be your guardian. So actually, as the owner of the wallet, you choose who's going to be your guardian and who is going to do your recovery. So you can choose a service that will require KYC. For example, in the future, you can imagine that your bank can do your recovery because you trust your bank, and then you can go to your bank and show your passport or do whatever KYC you are set by your bank, and they will act as your guardian. But it doesn't need to be that. It can also be you with a hardware wallet. So you can choose to have a hardware wallet, and your hardware wallet is acting as your guardian. Or you can ask a friend because you trust him. So it doesn't matter. And what's important to know is that you always remain in control. So as the owner or the main signer of the account, you can enable someone to be your guardian, but you can revoke that right at any moment. So you really remain in control, and you choose what kind of service you want to have for your recovery. So in the first phase, we as Argent will provide a service, simple for users, but the protocol, in a sense, it's a protocol that's open. So anybody can actually create a recovery service based on different, KYC or verification mechanism.
Great. One question from the chat is, can a signature be stored in a smart contract to be used for a transaction in the future?
I mean, yes, conceptually, yes, there's no reason why that would not be possible, but I'm not, depends on the use case. I'm not sure I see the use case for that, but yes, you can store whatever data you want in the smart contract. The signature on Starknet is just two fields. So you can store two fields in the smart contract and use them at a later point if you can trigger that.
Wonderful. Yoav, if you want to add anything, feel free to jump in.
I want to make sure that whoever asked this should consider the security of this very, very thoroughly. All right, very thoroughly to understand that he doesn't open himself up for getting pwned.
Wonderful. The next question, I see both of you answered this question, Yoav and Julien. The question is, we need to deploy an account contract, but how does the network prevent spamming since we don't have an ETH to pay for the deploy transaction?
Yeah, that's a very good question. The real answer is that it's still to be defined. So Starknet is still, the StarkWare team is still working on that. The idea, I would say the happy path is that the account will pay for its own deployment. And how can you do that? You can do that because the address of an account is actually, can be computed counterfactually, like create two on Ethereum, which means that you can actually know the address of an account before it is deployed. And so you can imagine a user flow when the user goes to ArjunX or Braavos, they say create a new account. Actually, we can show the address, we can show all the functionalities of the wallet, except that there's no code deployed, but we know the address at that point. And of course, the user wants, say, to buy an NFT, they need to fund the wallet to make that transaction in any way. So they will send ETH to that address. So now there is a balance, there is still no code. At the moment, the user wants to do that first transaction, we can transparently deploy the code of the contract at that moment, and the account will pay for its own deployment. So that's completely transparent to the user, and I think that's the best UX possible. From a technical point of view, it is a bit complicated because if you want to prevent the network to be abused, it means that you need to be able to prove failed transaction on Starknet, and the StarkWare team is still working on that. So that's the happy path. If that's not solved, but again, I have full confidence on the StarkWare team. These guys are amazing, so I'm sure they'll figure it out. But if that doesn't work, you can do something that we are doing today on L1 with the Argent Vault, is that you have a relayer that will pay for the creation of an account if you want. So you can kind of pre-sign the reimbursement, and then you give that signature to a party and say, hey, can you pay for the deployment of my account? And you have the guarantee that the deploying party will be paid back. The problem is that requires an infrastructure. I mean, we've been doing that on L1 for 4 years, and I think it kind of defeats the point of account abstraction. So ideally, what will happen is what I described first, is using create2 and the account paying for its own deployment.
Wonderful. Do you have anything to add on this question?
No, great answer, Julien.
Wonderful. We have a follow-up question about the security parts to Yoav. The question is, would you please elaborate on why it would be risky to store the signature to be used in the future?
All right. So first of all, you'll have to guess the nonce, right? And second of all, you will be open yourself up. If you're ignoring the nonce somehow, I don't know how, but you want to do it, you will be opening yourself up to a replay attack. So someone can replay your transaction with that signature because the signature is valid. And if you store it in the contract, then everyone can see it, right? Because it's on chain. And so you're opening yourself up to a replay attack. Again, I don't know exactly what your use case is. What I'm saying is if you're planning to do such a thing, first of all, I don't know, maybe my gut feeling tells me that don't do it. But if you insist on doing it, then make sure that you covered every possible scenario of replay attacks or nonce replay, or I don't know. It sounds like a bad practice anyhow.
Wonderful. I think that's a very clear answer. And I think our last question, I think it can apply to everyone, Tarrance, Julien, and Yoav. Our last question is, I want to create my own wallets. I've been looking for tutorials, but there are not so many available. Can you give some direction, resources to learn to create a wallet from scratch?
Yeah, so first of all, you have the Open Zeppelin's account contracts available open source as a reference. As they have a bunch of contracts implemented, as well as account contract and proxy contract. So this will be a very good place to start. Like it is the baseline reference for contracts. And I guess for UI, just like Julien said, and I'll let him answer as well, like you can take a look at Starknet.js and get Starknet, and this can get you going in terms of UI.
Yeah, I was going to say the same. Check Open Zeppelin. You can also check the Argent account because our code is open source. And I guess in a couple of weeks, you can check Braavos as well. So just look at the existing account contract and build your own. Yeah. And from the UI point of view, again, ArjunX is open source, so you can certainly find inspiration there.
Wonderful. Tarrance, do you have anything to add about what resources to look for if anyone wants to start a wallet from scratch?
Not particularly. I mean, I think that's like really, the go-to places. You have the Cairo, the Open Zeppelin contracts, Starknet.js, Ethers.js has some functionality for creating wallets. You can kind of look at that prior work and build stuff based off that.
Wonderful. I think we'll have one last question for everyone. The last question would be, are there challenges with wallets on mobile?
That one I can jump first because Argent has been building a mobile wallet for 4 years, and no, there is none. Of course, it depends on how you want to build. For example, today the Starknet.js, if you want to build native on mobile, then you will need something in Kotlin or something in Swift to interact with Starknet. But actually, we have started that discussion with StarkWare, and there was a contractor software mentioned that we start building a client in Kotlin/Java. I don't know exactly which one they will choose, but other than that, there's no other difficulty. Personally, I believe that mobile is the future. We believe that at Argent for the past 4 years, but we are still in a phase where a lot of people want to do stuff on their browser. But we believe at Argent that in the end, your wallet should be in your pocket, should be under your control, so it should be mobile. But then you can interact with browser through protocol like Wallet Connect, for example. So we believe that that's the future, and this will come to Starknet, I'm sure, very soon. But yes, no special difficulty to build on mobile.
Totally agree. We also need the dApps there, so it's also a challenge, but I totally agree with everything that Julien said.
Yeah, definitely. And I think in particular for gaming, I think like especially the types of games that were seeing built out on Starknet today, mobile is going to be especially important to support.
Wonderful. I think we'll adjourn the whole session now, and thank you everyone, including Julien, Yoav, and Tarrance. And I think there were around 60 participants listening in and learning all about Starknet Wallets. And thank you everyone. This was a very quality session that we've had so far. A lot of questions and very thoughtful answers from the mentors and speakers for this session. So have a good day, everyone, and let's start tinkering.
Thank you, everyone. Bye-bye.
Awesome. Thanks for having me. Bye. Thanks, guys.
Cheers.